All right, now that we've talked about switching, let's talk about some advanced features of switching and what switching has to offer. So PoE, or Power over Ethernet, allows us to deliver power over the same cable that we deliver data to. And it actually can be delivered straight from the switch. And so we typically see, like, small devices may need a data connection into it, and they may also need power. Well, we may have to plug this in to the wall to give this device power. And now we have two cables that are running to that device, which can be just cumbersome to deal with, but it also could be very tricky. For instance, some access points and maybe there's some sort of building IP system, and it's in a difficult to reach place. To get data there might be somewhat expensive, but to get power there could be quite a bit more. Dealing with high voltage lines to get power to a location can get very expensive. And so what we can do is we can deliver power instead over our Ethernet cables, doing away with the need as for a separate power line. So we typically see this with our smaller devices, such as wireless access points that can be in difficult to reach places, but it also could be like your desk phone if it's a VoIP phone, and then you plug in the cable into it, and there is this discovery that happens between these two devices, and then the switch will deliver power to that device, so that power does not need to be plugged in, and that's Power over Ethernet. Now, there are times when you want to group up certain groups of people or certain workstations or certain objects within your network into separate networks, or what you want to know what's called segmentation. You want to move apart different areas of your network for maybe some sort of security reason or for management of those services. So an example of this is maybe we have a couple machines here, and they both belong to let's say it's at your company and they belong to the HR group, and you want your HR group to remain separate from, maybe you have some sales machines over here, and those are two different areas. Well, what you may have to do is get two different switches to manage those two different networks. Or we can implement something like VLANs. Another example of this is you might have devices out there like access points that you want part of a management VLAN that's not part of your regular VLANs. And so this would be an example of that also. And then you also have a phone out here. We know that phone needs some sort of quality of service involved, and so we may want to dump that onto a separate segment that's all by itself, that's not within the other networks, and that allows us to control that data separately. And so once again, we could do that with separate switches, which could get very costly, or we can do it through the use of VLANs. So there's a lot to VLANs, and the idea of this is just to have it kind of an upper level view of VLANs. But what we're going to do is we're going to talk about VLANs, of what it might look like. And so here we have a physical switch right here. And what I can do is I can go and say, well, even though it's one physical switch, I actually want to segment it or break it into smaller components. So this right here could be a VLAN, or it could act as a separate switch. These 4 ports, and maybe these 4 ports are separate. Perhaps I have a port right here that I want to be a part of the same VLAN as this port right here, so we can break it up differently. And so we can assign these different ports to be part of different VLANs. So perhaps in my example, this is the HR ports and are going to connect to the HR, versus these right here are the sales ports and going to connect to sales. This could be an uplink port that connects to other equipment, and this could be what connects to our access point. And perhaps these are not assigned yet. And so we have different ports that are assigned to segment that traffic and keep them separated. So that's the idea of virtual LANs, or VLANs. One thing we may want to do on our networks is monitor the traffic that's going across it. So in this example right now, we're going to be talking about port mirroring and how to monitor traffic from another port. So we've got a router that's connected here, and all devices have to go out that router to get out to the internet. Perhaps we want to monitor that traffic and make sure that there's nothing nefarious either going out or coming into our network. So what we can do is we can set up, if this is on, let's say, port 8 on here, we can set up a server on port 7 that mirrors all the traffic that's going out port 8. And so all of this traffic that's going out port 8 will also be sent to port 7. And then this server right here might have special software that takes that traffic and analyzes it and starts looking for any kind of behavior that wouldn't be acceptable on the network. So one example of this is I used to work in schools, and any of the traffic that was going out to the internet would be also sent to a server that would take a look at what sites the students were going to. If they found that there was some sort of site that the student was going to that they weren't supposed to be going to, this server then would reply back to that client, that user, and say, you're not supposed to be going to that site. That site is blocked. And so that's an example of port mirroring where the traffic going out port 8 was also going out port 7, so that way a server could monitor that traffic. Another thing that can happen on your networks is somebody can take a device in there into your networks and plug it into your switch and start sniffing out your network, start discovering. In fact, I've actually had security companies that I've worked with, they'll give you a little device and then you'll go and plug that device into your network and it will start scouring your network and looking for holes within your network. And so there are devices out there that you don't want plugged into your network. So somehow you want to stop them from plugging those type of things into your network. So that's where port security comes in, is for every port on my device, I can lock that port down to only allow a certain number of devices on there, or only allow certain devices that have a certain MAC addresses on there, or some sort of authentication that happens per that port. So there's different ways to lock down that port, so that way we limit the type of traffic or the type of clients that are going on there. We can somehow limit the traffic that's going to be coming into that port. And so that's port security. A lot of different ways that we can implement port security onto that switch, but somehow we are limiting who can actually connect into those devices and communicate across that switch. So as our networks grow, so does how complicated our networks can be. Here we have the tier 3 core distribution and access layers, and we have a lot of redundancy within our connection. The problem is layer 2 doesn't like redundancy, not from an Ethernet standpoint at least. What can happen is you can get loops. As broadcasts happen, a broadcast could go out, could hit a switch, it gets broadcasted in all other directions, and from there you could get what's called a broadcast storm, where these broadcasts just start going in loops and start hitting your whole network. And so that can actually crumble your network. It could bring it down to its knees. And so what you have to do is you have to implement something like spanning tree protocol if you're going to have redundancy in your network. And so what spanning tree protocol does is it allows these different switches to communicate and find the fastest route to where it needs to go. And so what will happen is there will be a lot of communication, and it will elect something called a root bridge, and we'll go into all of that as we get further along. But the spanning tree protocol will allow there to establish a hierarchy within your network, and then it will actually shut off some of these redundancy lines. However, if something gets severed and communication stops happening, then it will then bring up those redundant lines. So it will stop these loops from happening, but still allow you to have redundancy within your network. So one other example of STP, even in smaller networks, even when you're not in these big redundant networks, is that I've had access switches where at the end of the year, school year at a school, the janitors will unplug all of the equipment. And then when they go to plug all the equipment back in, a switch will get double plugged into each other, and these devices then will once again create this loop where it creates a broadcast storm, and it will cripple the whole network. Even though it's only isolated to a small section of the network, it will cripple the whole network. And so what you need to do is what Spanning Tree Protocol once again will do is will recognize when something is plugged into itself, and then go through the process of taking one of those lines down, so that way you don't have this loop and have your network prone to these broadcast storms. Ethernet has a maximum transmission unit size. So equipment needs to know how big frames are going to come through it. And by default, the payload of a frame can only be 1,500 bytes. And so we've got a maximum size for that, so the equipment knows how to handle the data that's coming through it. There are some cases where this is not necessarily the ideal, where we have some fragmentation that's going on, or we have some really large bytes of data that are going on. In fact, my example here, I've got a data center here that's plugged with top of the rack switching. We've got our servers, and we got the storage. And when things are connected into storage, it ends up being larger bytes of data that needs to be sent to these storage units. And so because of that, it could be inefficient to have a maximum transmission unit of 1,500. And so what we can do is we can go to those devices, to that network addressable storage, to those servers, to those switches, to all the devices within this local area network. And we can specify that we want to use jumbo frames. And jumbo frames brings that maximum transmission unit of 1,500 up to 9,000. And so what that will do is that it's going to save you some traffic, some overhead, by allowing a much larger maximum transmission unit. So now as these servers are communicating with this storage, it can send much larger bytes of data. Hope this video is helping you out. Can you help me out by hitting that like button?